More than 700 imaging satellites are orbiting the Earth, and every day they beam vast oceans of information, including data that reflects climate change, health, and poverty, to databases on the ground. There is just one problem. While the geospatial data could help researchers and policymakers address critical challenges, only those with considerable wealth and expertise can access it. Now, a team based at UC Berkeley has devised a machine learning system to tap the problem solving potential of satellite imaging using low cost, easy to use technology that could bring access and analytical power to researchers and governments worldwide. The study, titled A Generalizable and Accessible Approach to Machine Learning with Global Satellite Imagery, was published in the journal Nature Communications. Satellite images contain an incredible amount of data about the world. But the trick is how to translate the data into usable insights without having a human comb through every single image. The researchers say they designed their system for accessibility so that one person should be able to run it on a laptop without specialized training to address their local problems. The project was a collaboration between researchers of different disciplines like computer science, environmental and climate science, statistics, economics, and public policy. But they have been guided by a common interest in creating an open access tool that democratizes the power of technology, making it usable even by communities and countries that lack resources and advanced technical skill. The system that emerged from the Berkeley-based research is called Mosaics, short for Multitask Observation Using Satellite Imagery and Kitchen Sinks. It ultimately could have the power to analyze hundreds of variables drawn from satellite data, from soil and water conditions to housing, health, and poverty at a global scale. The research paper details how Mosaics was able to replicate with reasonable accuracy reports prepared at a great cost by the US Census Bureau. It also has enormous potential in addressing development challenges in low-income countries and to help scientists and policymakers understand big-picture environmental change. The satellite data could give researchers deep new insights into expansive rangeland areas such as the Great Plains in the US and the Sahel in Africa, or into areas such as Greenland or Antarctica that may be shedding icebergs as temperatures rise. These areas are so large, and to have people sitting there and looking at pictures and counting icebergs is really inefficient. But with Mosaics, we could automate that and track whether these glaciers are actually disintegrating faster or whether this has been happening all along. For a government in the developing world, the technology could help guide even routine decisions, such as where to build roads. The growing fleet of imaging satellites beam data back to Earth 24/7, some 80 terabytes every day, a number certain to grow in coming years. But often imaging satellites are built to capture information on narrow topics, supplies of fresh water for example, or the condition of agricultural soils. And the data doesn't arrive as neat, orderly images like snapshots from a Photoshop. It's raw data, a mass of binary information. Researchers who access the data have to know what they are looking for. Merely storing so many terabytes of data requires a huge investment. Distilling the layers of data embedded in the images requires additional computing power and advanced human expertise to tease out strands of information that are coherent and useful to other researchers, policymakers, or funding agencies. Inevitably, exploiting satellite images is largely limited to scholars or agencies in wealthy nations. In low-income countries, one dimension of poverty is a poverty of data. But even communities in the US and other developed countries usually don't have ready access to geospatial data in a convenient, usable format for addressing local challenges. Machine learning opens the door to solutions. In a general sense, machine learning refers to computer systems that use algorithms and statistical modeling to learn on their own without step-by-step human intervention. What the new research describes is a system that can assemble data delivered by many satellites and organize it in ways that are accessible and useful. There are precedents for such systems. Google Earth Engine and Microsoft's Planetary Computer are both platforms for accessing and analyzing global geospatial data with a focus on conservation. But even with these technologies, considerable expertise is often required to convert the data into new insights. The goal of Mosaic is not to develop more complex machine learning systems. Rather, its innovation is in making satellite data widely usable for addressing global challenges. The team did this by making the algorithms radically simpler and more efficient. Mosaic starts with learning to recognize minuscule patterns in the images. The researcher compares it to a game of Scrabble in which the algorithm learns to recognize each letter. In this case, however, the tiles are minuscule pieces of satellite image, 3 pixels by 3 pixels. But Mosaic doesn't conclude this is a tree or this is pavement. Instead, it recognizes patterns and groups them together. It learns to recognize similar patterns in different parts of the world. When thousands of terabytes from hundreds of sources are analyzed and organized, researchers can choose a village or a country or a region and draw out organized data that can touch on themes as varied as soil moisture, health conditions, human migration, and home values. In a sense, Mosaics could do for satellite databases what Google in the early days did for the internet. Map the data, make it accessible and user-friendly at low cost, and perhaps make it searchable.